We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, myself NIMESH GANDHI, working as an assistant professor in Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Today we are going to discuss about different cases of vapor compression refrigeration cycle.
We are going to discuss about types of vapor compression cycle, or we can also say that different types or different cases of vapor compression refrigeration cycle. First case is cycle with dry saturated vapor after compression. Second case is cycle with wet vapor after compression. Third case is cycle with superheated vapor after compression. Fourth case is cycle with superheated vapor before compression. And last one is fifth case, cycle with undercooling or subcooling of refrigerant. So now we are going to discuss about first case. In first case, theoretical vapor compression cycle with dry saturated vapor after compression. Now you can see here pH, it means pressure and enthalpy diagram is there, and temperature and entropy diagram is there. First of all, I am just giving the overview of the pH diagram. In pH diagram, that region is your subcooling region. That region is superheated region, and inside region is region is called as a wet region. Now we are going to discuss about that curve. That curve will be considered that is your saturated liquid line. That is your saturated liquid line. This side will be your, that line is called as a saturated vapor line, and both are merged at one point. That point is called as a critical point. Now according to our theory, one case is given, dry saturated vapor after the compression. So we can say that in VCR cycle 1 to 2 is compression process. Okay, so after the compression, that case will be given dry saturated vapor. It means second point is directly given on saturation curve, dry saturated vapor. Now in compression process, compression will be take place, and during the compression pressure and temperature is increasing. So we can say that if we are consider first point is wet region, so it will be possible to try to convert in the dry saturated vapor after the compression. So first point will be considered in wet region. Then after the compression, pressure and enthalpy is increasing as well as temperature is also increasing. So at the time that wet refrigerant is converted into dry saturated vapor after the compression. Now 2 to 3 is a condensing process. So during the condenser, that dry saturated vapor is converted into saturated liquid. It is only possible when that latent heat of the refrigerant which is given up, or we can say given by the surrounding air. At that time, that will be your saturated vapor is converted into saturated liquid, and during this process pressure and temperature is constant. Why pressure and temperature is constant? Because during this process latent heat is give up, and latent heat is give up, it means temperature remain constant and phase change is possible. So that dry saturated vapor is converted into saturated liquid. Now 3 to 4 is your isentropy. We can say that 3 to 4 is your irreversible adiabatic process, or we can say that throttling process. During this process pressure is reduced and enthalpy remain constant. Then after 4 to 1 is your evaporator process, or we can say that heat absorption process, and during this process pressure remain constant, phase change is possible. So some amount of wet refrigerant is increasing its temperature remain constant. During this process temperature remain constant, we are absorbing the heat from the cooling space. So at the time some amount of your enthalpy is increasing. At that time it will becomes a first point. So at that time fourth and first point your wet region, second point your dry saturated vapor is there, and third point your saturated liquid is there. Similarly, now we are going to discuss about the temperature entropy diagram. Now you can see here temperature entropy diagram, one curve is there similar way. Okay, first that region is your subcooling region. Similarly, that is your superheated region. Inside your will be a wet region is there. That side will be a saturated liquid is there. That side will be a saturated vapor is there. Similar way, we are just consider 1 to 2 is compression process. So during the compression process, entropy remain constant. Why entropy remain constant? During this process we are not supply or rejecting the heat. It means entropy remain constant. So you can see S1 is equal to S2, and during this process temperature is increasing, so wet refrigerant is increase their temperature, so it become a saturated vapor. 2 to 3 is a condenser process. So during the condenser, latent heat is give up to the surrounding. If latent heat is give up to the surrounding, so at that time temperature remain constant because phase change is possible. That saturated vapor is converted into saturated liquid. 3 to 4 is your we can say that irreversible adiabatic process. So during this process some amount of entropy will be rise. So you can see here S3 to S4 some amount of your entropy will be rise, and during this process temperature is decreasing. And 4 to 1 is your heat absorption process. So during heat absorption process at pressure remain constant, entropy is increasing. Why entropy is increasing? Because we are absorbing the heat from the cooling space. So you can see 1 2 3 4, it will be your TS diagram for this case. Now we are going to discuss about the enthalpy equation and entropy equation. So first you can see that first we are just going to discuss about the first point. You can see here H1. So how to determine the enthalpy of that H1 point? So we can first initially we can say that we know about the enthalpy of that fluid at saturated liquid curve and enthalpy of the vapor at saturation dry saturated curve. We know about that value HF, that will be your Hg, but we require the H1. So how to determine H1? So it will be considered H1 is equal to that much portion will be considered, that is your HF. Then after first point is your wet region is there, and wet region, that wet first here that dry saturated liquid is try to convert into dry saturated vapor, so phase change is possible. So at the time during this region wet region is there, and wet region will be considered, latent heat will be considered, and latent heat will be considered. So at the time dryness fraction is also present, so we are just consider dry plus dryness fraction, that is your X. X is indicated how much amount of vapor is present in liquid refrigerant, and HFG means your latent heat, so that portion will be considered as a X into HFG. So it will be considered H1 is equal to HF plus X HFG. Why I should write here lower side? So we are considered it will be our evaporator side, and evaporator is our lower side is here. Now we are going to discuss about the H2 enthalpy, how we can determine the H2. So H2 point is directly on saturated curve. So saturated curve enthalpy we can directly determine. So how it will be considered? It will be a saturated vapor side is there. So we can directly take H2 is equal to Hg, enthalpy of the vapor. It will be considered higher side, condenser side will be considered. So we are just here writing higher side is there. Similarly, now we are just consider for the H3. So we can directly take H3 because H3 on saturated curve is there, saturated liquid is present. So we are just consider HF. If you are consider vapor, Hg will be considered. If you are consider the liquid, so HF will be considered here. Okay, it will be considered higher side. So similarly, we are just consider H3 is equal to HF. Okay, then we are going to discuss about the H4, how to determine H4. So you can see here throttling process, enthalpy remain constant, H3 is equal to H4. I just write H3 is equal to H4. Similar way we are just going to discuss about the entropy side will be considered. So entropy equation will be considered. First that point is your SF, that point will be your SG. SF means entropy of the liquid and SG means entropy of the vapor, but we require that first point entropy, that is your S1. So how we can determine? So you just consider SF will be considered, SF in this direction it will be a positive is there, plus dryness fraction is present in wet region, so it will be considered X into SFG at lower side. Now we are going to discuss about the S2 point. S2 on saturation curve, vapor side is there, so you can directly take S2 is equal to Sg. Or we can also say that S1 is equal to S2 because isentropic compressor process, entropy remain constant, S1 is equal to S2. You can directly take S3 is equal to SF. Why SF? Because SF entropy of the liquid side we can directly find out on saturation curve, at higher side is there, so you can directly take S3 is equal to SF. And then last one will be your S4. So how we consider? S4 is also in wet region. Similar way we have just consider, you just consider that SF will be considered, and that portion will be how to consider? You just consider dryness fraction into SFG. So we can easily find out H1, H2, H3, H4, S1, S2, S3, S4. Now how to determine the performance of this cycle? So performance of this cycle will be determined by the coefficient of performance COP. So it is a ratio of refrigeration effect divided by required compressor work. So how we can determine the refrigeration effect? If you are considered for the refrigerator, refrigeration effect will be determined at the evaporator side will be considered. So evaporator enthalpy difference will be considered, and evaporator side enthalpy difference is H1 minus H4. Why we are considered H1 minus H4? So you can see here H1 is maximum compared with the H4. So H1 minus H4 will be considered divided by required compressor work. So compressor enthalpy difference, compressor process 1 to 2 is there. So you just consider H2 minus H1 maximum minus minimum. Then after we can also say that H1 minus H3 divided by H2 minus H1. Why we are considered? Because H4 is equal to HF3, you can see here. Now we discuss about the case 2. Theoretical vapor compression cycle with wet vapor after compression. First of all, you can similarly say pH and TS diagram according to case 1. Already I discussed about the subcooling region, superheated region, wet region, similar way for the pH diagram as well as TS diagram. So we can directly start the case 2. First of all, condition is given that wet vapor after compression is given. So we all know about the 1 to 2 is compression process. So second point is directly given, wet vapor given after the compression, wet vapor is given. So obviously we can say that first case is also wet vapor is possible. So 1 to 2 is compression process. During the compression, pressure is increasing, enthalpy is also increasing, temperature is also increasing. But here concentration of the here vapor and refrigerant, here vapor refrigerant is less compared with the here. If I consider here the vapor refrigerant is more compared with the liquid refrigerant. Now 2 to 3 is condensing process. During this latent heat give up, pressure constant, enthalpy is decreasing. Similar way, saturated liquid is there, phase change is possible, saturated liquid. 3 to 4 is expansion process, enthalpy constant, H3 is equal to H4. 4 to 1 is our evaporation process, or we can say absorption process. During the absorption process, we are absorbing the latent heat from the surrounding. It will be considered. So at that time, that will be our absorption will be QA is there. That will be 4 to 1 process. During this process, pressure constant, enthalpy is increasing. You can see pH diagram. Now, similar way we are going to first point, how to determine the enthalpy of the first point. Similar way I just tell you in previous case HF, for that your enthalpy of the liquid, here the enthalpy of the vapor is present. We require H1. H1 is your wet region is there. So how to determine enthalpy of the wet region? And wet region, it means liquid plus vapor both are present. So first of all, initially we have just considered that will be your HF is there. Then after that much enthalpy is required. So how it consider wet region? It means dryness fraction is present. Dryness fraction means liquid plus vapor both are present, but the concentration of the liquid vapor we can find easily with the help of the X1. Then after it will be considered HFG. HFG, it means your enthalpy of latent heat of the liquid plus vapor. So it will be considered XHFG. So we can easily find out H1 is equal to HF plus X HFG at lower side. It means vapor side will be, evaporator side will be find out. Now we have discussed about the H2 point. H2 point is also wet region is there. So similar way we have just considered. So how it considered, but it will be our upper side is there, or we can say that higher side is there. So enthalpy of the higher side will be considered. So it will be considered first, that point is considered, that will be your HF, that side will be your HG zone on saturated curve will be there, enthalpy of the liquid, enthalpy of the vapor, but we require the H2 point. How we can determine? So you just consider first H2 is equal to that HF will be considered plus that distance. How it considered? So it will be considered X into HFG, dryness fraction into latent heat. So it will be considered at higher side will be considered. Then after H3 will be determined. So H3 is directly we can easily find out on saturation curve. So H3 is equal to HF3 at higher side, and H3 is equal to H4. So we can easily find out the H1, H2, H3 and H4. Now we are going on the TS diagram, entropy and temperature and entropy diagram. So how we can determine S1? Similarly we can find out S1 is equal to first SF, entropy of the that liquid is there, here entropy of the vapor is there. So we can find out S1 is equal to SF plus XSFG, that your XSFG will be considered at lower side. Similarly for the higher side will be considered. So how to determine S2? So similar way we have just considered, that point will be considered SF, that side saturation curve vapor is at SG, but we require S2. So how we consider? That will be considered SF plus XSFG. At higher side will be considered. Then after S3 is equal to SF3 on saturation curve is there and liquid side is there, so SF3 will be considered. Over. Then after how to determine S4? So S4 will be one more time wet region is there. Whenever wet region is there, dryness fraction is present, and dryness fraction will be considered. So how it considered? It will be considered with the latent heat into dryness fraction, or entropy at gas side and vapor side into dryness fraction will be considered. So we can similar way at SF will be considered into that much distance is required. So how it consider? SFG. Now already I told you X1 is there, X2 is there and X3 is there, which is indicated dryness fraction, the concentration of the vapor is present in the liquid refrigerant. Now we are going to discuss about the coefficient of performance of this cycle, how to determine. So we can similar way determine refrigeration effect divided by required compressor work. You can see here. Now refrigeration effect evaporator side will be considered H1 minus H4. Similar way compressor work will be considered H2 minus H1. Now H4 is equal to H3 we can say that. So H1 minus H3 divided by H2 minus H1. Now we are going to discuss about the case 3, theoretical vapor compression cycle with superheated vapor after compression. This case is also we can say that ideal case for VCR cycle. Normally we are using this case for the VCR cycle. Already in mentioned theory that superheated vapor after the compression is there. It means I already told you that the subcooling region, wet region and superheated region. The second point is directly given superheated region is there. So obviously two possibilities there. या तो first point is your saturated vapor is there, otherwise first point is your superheated vapor will be there. But if you are consider ideal VCR cycle, so normally we are consider first point is your saturated vapor is there. So first point directly we are consider saturated vapor, then after it will be compression process. So during the compression that saturated vapor is converted into superheated vapor. How it possible? Because during this process temperature is increasing, pressure is increasing, enthalpy is also increasing, but entropy remain constant because we are not supply or rejecting the heat. It means entropy remain constant. S1 is equal to S2. You can see here S1 is equal to S2, entropy constant, enthalpy is increasing, pressure is also increasing. 1 to 2. Then after now 2 to 2 days, now we are going to discuss about the 2 to 2 days first. Now 2 to 2 days is your desuperheating process. During this process that superheated vapor is one more time converted into saturated vapor. Then after it will be converted into saturated liquid in condenser, give up its latent heat to the surrounding. We can also say that that process is sensible cooling. During this process temperature is decreasing from T2 to T2 dash. You can see here T2 to T2 dash. So during this process phase change is not possible. Just superheated vapor is converted into saturated vapor. So that process is called desuperheating process. Then after 2 days to 3 days is condensing process, latent heat give up. So at that time phase change is possible. Saturated vapor is converted into saturated liquid. 3 to 4 is a throttling process. So during the throttling process enthalpy remain constant. H3 is equal to H4 and pressure is decreasing, P3 to P4. Then 4 to 1 is your evaporating, or we can say heat absorption process. We are absorbing the heat, latent heat from the cooling space. So at the time that wet refrigerant is converted into saturated vapor, we are absorbing the heat from the cooling space. That will be your pH diagram. Now we are going to discuss about the TS diagram. Already I told you isentropic process, entropy constant. So S1 is equal to S2, temperature is increasing, T1 to T2. During this process, there is desuperheating process. During desuperheating process, temperature will be decreasing, T2 to T2 dash. Then after during the condensing process, it will be phase change is possible, that saturated vapor is converted into saturated liquid, and during this process temperature remain constant because phase change is possible and entropy is decreasing because we are rejecting the heat to the surrounding. Then 3 to 4 is your expansion process, or we can say that irreversible adiabatic process. Irreversible adiabatic process, during this process some amount of entropy will be increasing, so you can see S3 to S4 some amount of entropy is increasing. During this process expanding, temperature is decreasing. And then after 4 to 1 is your absorbing process. So during absorbing process we are absorbing the heat from the cooling space. If you are absorbing the heat from the cooling space, so at that time entropy is increasing, temperature remain constant because phase change is possible, wet refrigerant is converted into saturated vapor. Now over pH and TS diagram, similar way we are going on the enthalpy equation, then after entropy equation. So first of all you can say that enthalpy equation we are just consider first. So enthalpy equation first, already I told in previous case that on saturation curve that will be your enthalpy of the fluid is there, and that saturation curve enthalpy of the vapor or gas is there. So our first point is directly on the saturated curve, so we can easily find out enthalpy of the gas at lower side. So it will be find out H1 is equal to Hg at lower side. Now second point is your superheated region is there, and superheated region dryness fraction is not present. So at that time how we consider? So you just consider first here to here, that will be your HF is there, here to here 2 dash point, Hg is there, enthalpy of the vapor is there, but we require H2. So how it consider? So at that time you just consider that much distance. How it consider? So it will be consider here vapor is present, so specific heat of the vapor is consider into temperature difference is consider, maximum minus minimum. You can see in TS diagram. In TS diagram T2 is maximum, T2 dash is minimum, T2 minus T2 dash will be considered. So how we consider H2? H2 is equal to enthalpy of the vapor, then after plus CPV specific heat of the vapor, T2 minus T2 dash at higher side. Over now H3, how we can determine the H3? H3 on saturation curve is there, liquid side is there, so you can directly take H3 is equal to HF3, and we can directly say that throttling process H3 is equal to H4. Over now we are going to discuss about the entropy equation. So first entropy equation, similar way according to the enthalpy it will be considered. So first point on your saturation curve is there, so we can directly find out that will be your Sg is there, so S1 is equal to Sg at lower side. But second point, your superheated region is there, so how it will be considered? So you can just consider that is our S2 is there. So first of all you know about that Sg, enthalpy of the vapor at higher side is there, so enthalpy of the vapor of the higher side is there. Then after that much distance how it considers? So you can just consider CPV specific heat F vapor ln T2 by T2 dash. Over then we discuss S3 on saturation liquid side is there, on the curve is there, so you can directly take S3 is equal to SF3 at higher side. Then last one will be your S4. How to determine it? S4 in your weight region is there. In previous case I already discussed about the weight region. So S4 is equal to SF plus XSFG at lower side. Now we can determine the performance of the jet cycle COP. COP is equal to similar way refrigeration effect divided by compressor work is equal to, that will be your evaporator side, and that side will be your compressor side is there. So H1 minus H4 divided by H2 minus H1, and similarly H4 is equal to H3 will be considered, so H1 minus H3 divided by H2 minus H1. Okay. Now we are going to discuss about the case for theoretical vapor compression cycle with superheated vapor before the compression. Already mentioned that before the compression the refrigerant is superheated vapor is there. Already I told about the each and every region, so we can directly start. First compression start for the superheated vapor refrigerant, so we can directly take first point of the superheated vapor is present, that is your saturated vapor, so we can directly take superheated vapor in your compressor is there. That superheated vapor one more time compress, so its pressure is increasing, temperature is also increasing, enthalpy is also increasing, but during this process we are not supply or rejecting the heat, it means entropy remain constant. So you can see S1 is equal to S2 entropy constant, temperature is increasing T1 to T2, then after pressure is increasing and enthalpy is also increasing. Then we are going to similar way 2 to 2 days, similar here 2 to 2 days will be considered Superheating process, it means that superheated vapor is one more time converted into saturated vapor. During this process, temperature is also decreasing, but phase change is not possible. Entropy is also decreasing because we are rejecting the heat. And during the condenser, that saturated vapor is converted into saturated liquid. At that time, it's give up its latent heat to the surrounding by air or water. Then third 3 to 4 point will be your enthalpy constant. We can say a throttling process. It will be considered H3 is equal to H4. And then after 4 to 1 is your evaporating, or we can say heat absorption process. So we are absorbing the latent heat from the surrounding. So at that time, that wet refrigerant is converted into superheated. Over pH diagram. Then after TS diagram, already I told about the 1 to 2 process, 2 to 2 days process. Now we are going on the 2 days to 3 process. It's your condenser process. During the condenser, temperature remain constant, give up its latent heat to the surroundings. So at that time, phase change is possible. Saturated vapor is converted into saturated liquid. Entropy, we are rejecting the heat. It means entropy is decreasing. Then 3 to 4 is your expansion process. Similar way, some amount of entropy will be increasing. Irreversible adiabatic process. During the irreversible adiabatic, entropy is increasing. S3 to S4 will be there. During this, expansion is there. It means temperature is decreasing. And 4 to 4 days will be considered as a, one more time it will be considered, it will be a heat absorption process. During the heat absorption, phase change is possible. Wet refrigerant is converted into saturated vapor. And then 1 days to 1 days is superheating process. During the superheating, temperature is increasing, entropy is also increasing. Now over pH and PS diagram, similar way we are going on the enthalpy equation as well as temperature equation. So first of all, we are start with the enthalpy equation. So for the first point, how to determine H1. So we can say that first, we already know about that 1 dash point is Hg on saturation curve. So now we require that much distance. So how it consider? Already I told you in previous case how to determine. So it will be considered as a specific heat of the vapor and temperature difference from, you can see here, T1 minus T1 dash. T1 is maximum, T1 dash is minimum, T1 minus T1 dash at lower side is there. Now how we can determine H2? Another superheated region is there. Similar way, whenever superheated region is there, so we can how to determine the enthalpy. So enthalpy will be determined by the H2, or we can say that H is equal to Hg plus Cp delta T will be considered whenever superheated region is there. Then after it depend on the point. The second point is there, so we have just considered H2 is equal to Hg for the higher side. Here Hg for the higher side, 2 dash point will be considered, plus that will be distance. How it considers? CPV T2 minus T2 dash, maximum minus minimum at higher side will be there. Then H3 on saturation curve is there. So saturation curve we can directly find out for the liquid. H3 is equal to HF3 and H3 is equal to H4 is there. So we can directly take throttling process. Now for the entropy side will be considered. Similar way, superheated region is there. Similarly we are consider how it will be considered whenever if you are consider the entropy. So how it will be considered? S is equal to Sg plus CPV ln T by T. It means T is indicated that for superheated temperature and T will be a saturated temperature. That will be considered. So you can see here S1 is equal to that distance up to consider, it will be your Sg is there plus that distance how it considers CPV ln T1 means superheated temperature and T1 dash means saturated temperature. Similar for the lower side is there. Similar the higher side will be considered. You can similar, both equation will be similar there. Just instead of 1 it will be considered, instead of 2 will be considered, but it will be considered higher side. Then after third point will be how to determine. Third point on saturation curve is there, so we can directly find out and entropy of the liquid at third point at higher side is there. And fourth point is wet region is there. Wet region already I told you how it considers. It will be considered entropy of the liquid plus dryness fraction into SFG for the fourth. Over now performance, how to determine the performance of that cycle. COP, refrigeration effect divided by required compressor work, is equal to refrigeration effect means cooling effect produced by the machine, which is your evaporator side, H1 minus H4 divided by required compressor work, H2 minus H1. Similar way, H4 is equal to H3 from here. So we can say that COP is equal to H1 minus H3 divided by H2 minus H1. Okay. Now we are going to discuss about the last case, theoretical vapor compression cycle with undercooling or subcooling of the refrigerant. First of all, here the initial condition of the compressor is not given. In previous 4 cases, initial condition of the compressor is given. But here the initial condition is not given, so we can directly consider the ideal condition. And ideal condition is what? First, first point is our saturated vapor is there. Then second point is your superheated vapor is there. Now we are going to discuss about what is subcooling. Is subcooling means what? Already I told you 1 to 2 process, compression process, so it means that saturated vapor is converted into superheated vapor. Then after this superheating process is there, then after that saturated vapor is converted into saturated liquid. Up to that over in previous case. Now we are only concentrated on the subcooling region. Subcooling, it means what? That saturated liquid is one more time cooled down with the help of the any other refrigerant, or we can say any other coolant is there, or air or water. So at that time its enthalpy is decreasing, pressure remain constant. So that region is called as a subcooling or undercooling region is there. Okay, in TS diagram you can easily see. You can see here already saturated vapor is there, saturated liquid is there, saturated liquid is there. One more time it will be cooled down. One more time it will be cooled down, it means its entropy is decreasing as well as temperature is also decreasing. So you can see here T dash to T, that is your T3 dash, and that will be your T3 is there. So that much amount of your temperature will be dropped. If you are considered superheated, temperature is increasing, but if you are considered subcooling, your temperature is decreasing. That is a basic difference between subcooling as well as superheating. Over 3 dash to 3 point is over. Now 3 to 4 is expansion, similar way. Constant enthalpy is there, then after pressure is decreasing, that will be there. Then after 4 to 1 is your one more time absorbing process, or during absorbing process weight region is converted into saturated vapor. Then remaining process will be same, just only difference is what? That is your subcooling in pH diagram as well as TS diagram. You can easy to see. Now we are going to discuss about the pressure. pH and TS diagram is over. Now we are going to discuss about the enthalpy for this and entropy. So first of all we are going to discuss about the enthalpy. So first H1 point, you can see easy to see here, enthalpy H1 point is on our vapor side is there, saturated curve side is there, so you can directly take that will be your Hg is there. But if lower side is there, so lower side will be considered Hg. H1 is equal to Hg at lower side. Now H2, so how it consider? Up to that 2 dash point you can say that Hg is there, but higher side is there, so it will be considered higher side. Then after that much distance, how it considers? So already I told you how it will be considered. It will be specific heat of the vapor side into temperature difference, maximum minus minimum. You can see here T2 minus T2 dash, maximum minus minimum, CPV at higher side is there. Over how we can determine, it is the most important condition for this case, how to determine the subcooling. If you consider superheating, we are going in this direction. So at that time we are considered that my sign is positive is there. But whenever if you are considered here, we require that H3 point. So how to determine? So we know about the value of the HF is there. That saturation curve is we can easily find out. Okay, higher side HF will be find out. But we require the H3. Now we are going in opposite direction. If you are going in opposite direction, so at that time sign will be negative is there. So you can see here negative sign is there. So it will be considered H3 is equal to first, up to that distance is considered HF minus similar way CPL is considered. Here CPV it means specific heat of the vapor is considered superheated region, and if you are considered subcooling region, specific heat of the liquid is considered, and temperature difference will be considered. So you can see in TS diagram temperature difference T3 dash minus T3 Z. It will be considered at higher side. Over, then after H3 is equal to H4 you can easily find out. Now entropy diagram. Over, now entropy equation, similar way entropy will be considered first point on saturation curve vapor side is there, S1 is equal to Sg. Second point is superheated region is there, so you can easily take S2 is equal to Sg plus CPV ln T2 by T2 dash. Now we are concentrated on the subcooling region. Now it will be considered S3 is equal to first, up to that distance you know SF is there, liquid entropy is there. Then after it will be minus out because we are going in opposite direction will be there. We require that point is there. So how it consider? It will be minus will be there, and that after that distance is considered. How it will be considered at distance? CPL. It means specific heat of the liquid ln T3 dash by T3. T3 dash by T3. You can see here both are different, superheated as well as subcooling. over, and then last one will be your S4 point is there, S4 is weight region is there, so weight region we can easily find out. Already I told you in previous cases SF plus X SFG at lower side. You can just consider condenser side is your higher side and evaporator is lower side. Similarly in pH diagram and pH diagram. Now how to determine COP? COP is equal to, it is a ratio of refrigeration effect divided by required compressor work is equal to evaporating or cooling effect. We can say that H1 minus H4 divided by H2 minus H1. H4 is equal to H3, so we can directly take H1 minus H3 divided by H2 minus H1. Over. Thank you.